I just won't say stuff.
Put your questions on your left. So like I don't have to read the whole question for you guys. You know what I mean? All right. I started recording. So go ahead and get your notes up. Can you guys see that? Oh.
No.
Screen.
Yeah, I don't think. Oh, there you go.
Awesome. Okay, so we're gonna start off with A. So for the truth table, five. Okay. So we have to find the value for each of the variables, right? So we have A, we have B, and we have A naught, B naught, and then each of these expressions. Well, that messed it up. I'll just do it like this. So what we're doing here is we're basically just finding if the value is 0 or 1. Right? Does that make sense?
Right. And the last one will have both of them.
Yeah. So we're going to put every possible value for each one of these. So it would be 0, 0, 0, 1, 1, 0, and 1, 1. And if we not A, 0 would become 1s, and 1s would become 0s, and same thing for B. You guys with me so far?
That makes sense, yeah.
All right. So we know that A is 1, and B naught is 1 as well. So what's 1 or 1? What does that turn equal to?
1 or 1 is 1.
Yeah, so the value for this is 1. And the next thing over here, it's 0 or 0, so that would turn to 0. And this one would become 1. Just tell me if I'm going too fast, and then I'll slow it down.
Honestly, with tables, it's like as soon as you see it, you know how to do it.
Yeah, exactly.
Mm-hmm. That's why I don't think you need to spend too much time.
Isn't the first A you did a 0?
Oh, yeah, sorry. Yeah, it was.
So that would equal... That's still 1 though, right?
Yeah, it would still be 1 because it's or. It's one or the other. If you see a plus sign, just always think if it's one or the other. And if it's like times, they have to both be true.
Okay.
And just in this one, it would become 1 or 1 equals 1. 1 or 0 equals 1. 0 or 1 equals 1. And 0 or 0 equals 0. And it would be 1
0,
and
1.
Let's make this one bigger. Alright. So since we know the value on this one, we can just kind of put it on there, you know. So 1 and 1 would equal to what?
1.
0 and 1 would be
0.
And same goes for the other ones. When I get a better one later, I'm gonna highlight it so like you guys know where the 0s and the 1s come from. But for now, just bear with me, trying to deal with time. Alright, so before we move on, I want you guys to know that V is an or, and this is and. So you guys don't get confused. I get confused all the time with this bitch. And we can make another truth table in this case, 7 columns as well.
This will have 6 columns, right? Because you don't need to know not P. Right?
Yeah, you don't. It's just like I'm really used to just doing it, like adding the extra one just in case. But now we don't need it in this situation, so it'll just be P, Q, Q naught, and both of these equations. Or I can simplify that for you guys. So it's P, Q naught, and the second one is P or Q. And the propositional logic. So you guys also have to remember this. So it's P. Whenever you see this arrow of Q, this actually just means Q naught the first value. Change that arrow to a plus and leave the Q as it is. Does that make sense?
Yeah.
So in this situation, you would not this part. You would not this. Put a plus here and leave this as it is. So it would be P naught or Q naught. No, Q or Q.
And Q.
Is it and? Oh no, we
the whole thing.
No, we knotted it, remember? So it would be an or. So
That's an or, so it gets knotted to become an and, right?
oh yeah. I told you I get confused all the time, bro. My bad.
Yeah, you're good.
And it's PQ. P or Q, right? Or is that and? Yes, and. Okay. Alright. So
Hey, can you zoom in a little bit? I'm just having trouble seeing.
is that better?
Perfect. Yeah,
Thanks.
that's so much better.
Yeah, sorry.
No, you're good. You're good.
Alright, just the same values as ones over here, right? And then when you knock Q, it would just become 1, 0, 1, 0.
1, 0.
So in this case, P would become 0 and Q naught is 1, so that would become 1.
Wait, that expression there, is the not on the outside because here it's on the inside, but for the main equation's on the outside of the parentheses.
Which one are you talking? This one?
Yeah, the little apostrophe there.
Okay, so the original equation was this. It was P.
Or not Q.
Yeah, what he said. It's because I have a cheat sheet, but I'm not really paying attention.
Well, I was just saying because if you what you have written, if you distribute that knot, the P would be knotted.
Yeah, it should have a knot at the end on the fourth.
Well, that wasn't the original. That wasn't the original equation.
Oh yeah, that wasn't the original. So
the original equation didn't have the knot on the outside.
All right, I just wanted to make sure there wasn't a mistake or anything.
yeah, you're right. So basically, what we're gonna do here is whatever we get here. So this becomes 0. It would become 1 over here because it was knotted, right? You'll see what I mean in a minute.
Oh, okay, I see what you mean.
Yeah. So P and Q naught is also 0.
That one isn't taking the knot into account. Okay.
Okay. So
Next one is 1 and 1.
thank you.
That's 1.
Just keep telling me so I have to look at it.
All right, the last one is 1 and 0.
Thank
1 plus 0, which is 1.
you. And
This one is 0 and 0. The next one is 0 and 1, which is 0. 1 and 0, which is 0, and 1 and 1, which is 1. So 0 and then 1. That's 1. And so you have hang on, for the implies, there's another way to do it where as long as the first one isn't true and the second one is false, then it's true. That's the way I looked at it.
okay. Well, okay. So we have the original value, right?
Mm-hmm.
And since you guys know, let's just do it like this, so you guys can see why. So knotted. It's basically this thing right here. Q knotted. No, this is not it. Okay. But we already have the value for the inside function, so since this is 1, that would just become 0, right? And same goes for the other one. So 0 and 0 would become 0, and then the knot of 0 is 1, So that would become 1. And the not of 1 would be 0. And this is 0. Are you guys confused with this part? Because I know like it's kind of weird, but
I'm
Only-
a little bit, honestly.
Only slightly, because my answers were true, false, but this is false, true, true. So,
oh, like why it's backwards, basically.
yeah, it could be just the order. No, it is definitely the order I put them in. I started with P is 1 1 0 0. Okay, that makes sense.
All right.
Can you go- oh, sorry.
Your last one should be 1 not or 1.
Oh, is it 1?
Yeah, maybe have like another column because it's kind of confusing having the knots in the bottom rows.
Like right here, like these.
Yeah,
Okay, we'll have another column then.
that's. I think that's where people.
Mods just definitely messed it up.
Can I switch these? No, I can't. Okay, so let's just do it like that. I freaking hate my computer sometimes.
So now we're doing P plus Q not.
Yeah, so we're gonna do this. So that would turn to the De Morgan's theorem. You guys know what the De Morgan's theorem, right? Is right?
Opposite everything.
So it'd be P naught Q. Does that make sense?
Yeah.
Yeah, so everything would be knotted in this case.
So just the opposite of the first column. So it'd be 0 1 0 0.
hmm
Wouldn't the very bottom right column's answer be 1 instead of 0?
Oh, because of the prime here, it turns 1 to 0. So you have to know that.
Yeah, but it's like PQ is 1 on that one, isn't it?
Yeah, PQ is 1, but the first one is 0.
Oh,
But this is an end function, so like it would be end.
are we not? I thought it was or.
No, it's end. Look right here.
Oh, shoot.
We switched it to and when he did the De Morgans.
Mhm.
Ah, okay.
Yeah, I should have added more columns. My bad.
So we're just doing the opposite of the fourth
Yeah,
column, right?
Yeah, it would just be the opposite of this one. So this would become 0, 1, 0, 0. Right?
So, for the like imply stuff, you just take like the De Morgans of the first part.
The negation
Yes,
of the
yeah.
first part.
Because
Right.
Wait,
No,
Jerome,
wait a
But
your
you'd
last
still
one
be
is
add-
wrong.
Yeah,
Yeah,
you'd still be
it'd be
adding it
or,
though.
actually.
Or is still there.
Yeah, I was looking back and forth. I'm pretty sure.
wait, what do you mean?
Look at B and look at the equation that you wrote down. That is not the equation you have on the last one.
Are you serious? Wait. Oh, so this would become 0. So this would become 1.
Wait, no. It's
That's it. That's the answer.
Are you?
Okay, so the
No,
last
no.
one, the top right,
Oh,
should be P or Q not, or PQ.
Yeah.
So it becomes 1. Oh shit. Oh shit.
That's the original equation.
Yeah.
Yeah, so it become right there. Yeah. Fuck. Okay, sorry. That's on me. Okay. So this would become Okay, let me just
It's a lot easier on this one to use the true false version rather than the zeros and ones. Because you only, as long as it's true and then false in that order, you don't even have to do any action.
exactly.
So you'll just get
If
true
the first
false.
one is true.
So you guys want to switch this to the true or false one if you want to do that one then?
Oh no, I mean it still works your way. It's just it's a little bit harder to understand. Honestly, if we have time, you could go back and do that, but I don't really. These are kind of
It
the
really-
problems.
Whichever one you did the most, it would be the one that's easier for you. But
Yeah.
I'm looking at
Yeah,
it.
these are the easier ones.
So you see the fourth column, how it's 1 0 1 1, and the 0 0 0 1. As long as whenever it has 1 first and 0 second, then it's false. That's what it's supposed to be.
Mhm.
No one's actually confused about this concept. I don't
No,
think.
no.
All right.
I think
Mistakes.
we can
The copy
move
paste.
on. Yeah.
All right, we'll move on. I just got kind of confused. Sorry. Okay. We're gonna do number 2 now.
Yeah. I have the work for this in my notes.
Yeah, it's fine.
I don't know how to do it.
No, I know how to do it. Don't worry. So it's xy plus x yada yada yada. That looks so weird. Are you guys used to the knots or are you guys used to the bar on top?
I'm good with either.
Alright, okay. Okay, so the first thing we can actually do here, the first step is we can rearrange it so it would look simpler to you guys. If that makes any sense. So we rearranged it, right? And since like right here, the frick. Alright, awesome. You can actually take the z naught from both of these values because it's one of the identities you guys have to remember. So it'd be z naught.
Interesting.
What was it? Z naught. Is it y or x plus z?
Times x naught plus y naught plus y naught y. So z naught times x naught plus y naught plus y.
Yeah.
And then that y
this
naught and
whole
y become
equation
1.
right here.
Yeah.
Yeah. So these two are going to become 1 because like y naught or y would just become 1 because it's zeros and ones. I'll definitely highlight that so you guys can see what's going on. Nobody's confused on this part, right?
Yeah.
Gotcha.
The highlighting helps, but he does it too much. My opinion.
I'll do it very
said-
minimal for you guys.
Because I commented one time the highlighting is nice, and then he just started highlighting so much. I was like, no.
So
What have I done?
So the
I don't get this.
the x kind of disintegrates the 1 kind of disintegrates after that because you don't really need the 1 in that situation. It's just very arbitrary at this point. And
Actually, ORing with 1 makes it 1.
mhm,
So you just get rid of the x naught as well.
So the 1 disintegrates.
Oh,
yeah,
yeah.
so that whole thing comes off. God, I'm rusty. So this whole thing disappears because x naught or 1 would just become 1.
See how that becomes x z naught plus x plus y. I don't understand.
Okay, you can actually distribute z naught right here in these two equations. So it would become z naught or x or y multiplied
That's what I
by
always
z
forget.
or z naught. Does that make sense?
Oh, I see it now. Now that makes sense. Yeah.
So you would
Distributed.
you would distribute this whole thing to each one, and that turns to this.
I see it now.
And this one becomes like 1, and your final answer would become z naught or y or x. Or if that gives you OCD, just flip it back around, bro. Alright, so this is the final answer. Did that make sense to you guys?
Looks good.
Yeah,
Now, I now understand that you distributed the z naught, so it became z naught plus z on. That's one half of it, and the other half is the z naught distributed with the x. Thank you.
Okay, so like I said a while ago, P arrow Q is equivalent to P naught or Q. So that's what we're going to do in this equation. So we would just simplify it to P and Q naught, the whole thing knotted, plus PQ, P or Q.
Yeah.
Wait, I have a question. Is it supposed to be P or Q in the first bracket though? Because you're nodding. That first I heard.
Okay, give me a second. Yeah, so that's right. And for the first one, we can do De Morgan's theorem. So it would be P naught times Q naught. Right? Does that make sense?
Yep.
And
Wait, isn't it just Q?
That becomes Q, my boy.
Yeah.
yeah, no, not that. And then since they both have common terms, you can just take the Q
Factor out.
out, yeah, and then do P naught or P,
Which is
Wait.
1.
which is 1, so that would turn to 1.
The whole
No.
thing.
It would
Turns
just
to
turn
Q.
to Q.
What happened?
It turns
It's
to
1
Q.
times Q.
It's weird.
Yeah, like the math is kind of whack, so like it's so different than the math we're used to, so like everybody's just like, what the
Yeah.
fuck is going on? Like
Exactly.
even I get confused, like what the fuck are we supposed to do? But
Exactly. That is the appropriate response.
So is our final answer here Q or 1?
it's Q. This,
Okay.
this turns to 1.
Yeah,
It would
the
just be Q.
P naught plus P goes to 1, but
Hey, Mr. Blue Waffle.
Yeah, what's up?
This would usually be like my saving grace. Can we post it afterwards too, so I can like print this out?
Oh yeah, for sure.
Cool.
I'll do that.
Thanks, homie.
I usually have like 3 versions of the reviewed, like this version, that version, and someone else's. Okay.
Sorry.
So the next one is like P.
What's up?
Yeah.
Yeah, go ahead. Don't worry.
I was just gonna say what it is. No. You basically use the implies rule twice for this one.
Mm-hmm.
No, you're doing a terrific job, Jerome.
No, yeah, for sure. No, it's because I just wanted to hear what you were saying. But all right, so I know people kind of know how to do it like real quick, but I want to do this one step by step because people get confused if they don't do it step by step like with Zwane.
Mhm.
Okay, so like this one and this one, we're gonna do the inside functions for the inside stuff first to make it simpler for you guys, right? We're just using this thing right here and just implying it to this. Make sense?
Mhm.
And then after that, we're gonna do the imply function for this, so it become
Not P.
yeah, so it'd be not P plus QR. And if it confuses you, you guys can actually just take these out because it messes me up personally, but that's on it. Just kind of depends on your preference. And this one would be P naught P and Q naught plus R. Then we're gonna simplify that on the next one, which turns out to be you can use the De Morgan's theorem for this one, right?
Exactly.
So it becomes plus R. And are they equivalent to each other?
They are.
So yeah, so that's a check right there.
That actually makes like way more sense than what he did in class.
Oh yeah. Okay, so we're gonna do B unless anyone has any questions.
Just leave it on the screen. Any questions though?
Gotcha. Tequila Sheila, I am gonna post it. I'm recording as we speak. Nice,
Thank you.
Yeah, nice name by the way. Okay, so Jesus Christ. All right, so right here we're just gonna do the implies rule first. So it's gonna be this whole thing knotted plus this thing. So I'll fix the indentations later. I know that bothers you guys.
Good.
All right, so we're gonna just do the De Morgan's theorem here. So it just become A naught and B naught or C naught, right?
Yeah.
Awesome. Okay. And then plus A or B and A and C. Do you want us to simplify here?
You know, for this one, all I did was distribute the V on the first part, made it A and A or B. And
yeah, we're checking to see if they're equal to each other on this one.
so yeah. So you just distribute A and B and A and C, and they're equally to each other in like 2 lines.
All right. Not gonna lie, I'm confused about what you're saying, so I'm gonna try to.
I'm sorry. So
No,
A,
it's fine. Okay.
A or B and C. So you make that, you distribute that to A or B and A or C.
So this whole thing.
Literally,
and then they'll be equal. So.
yeah. So in one line, the top part will equal this. Well, it'll equal it. Won't imply it, but it still equals it.
Okay.
Or you just sorry.
No, it's fine. It's just I don't know what you're saying. You know what I mean? Like I know it's probably right. It's just that kind of confused.
No, I'm not saying it right.
So basically, what happens is you're gonna take that A and distribute it to the B, C that are ANDed together on the left hand side, and then you're gonna get A plus B ANDed with A plus C, exactly like what's on the right hand side, which proves it true.
Oh, so we're just checking if these are equal to each other.
I mean, I think.
So we can try that. So it would be A. Is that or? So it's A or B.
Yeah, that's or. I hate when they write it like that. It just annoys me.
Yeah, V and the backwards V is kind of like, what the fuck?
Yeah.
What the fuck are you trying to say, mate?
I hate the notation that you can't even write with your keyboard. Like,
yeah. Are they expecting us to use that notation? Because I'm not going to do that.
Probably not.
She's probably gonna say just write V or like Shift 6. It's not gonna. Be...
See, I don't think they're equal, in my opinion.
But if they imply, they have to be equal, right?
Wait, so it's gonna be A or B times A plus C, right?
But that is a good point, Jerome.
Yeah, because the problem is like they are equal, but the problem is because of this proposition, this is gonna switch to not this whole thing, right?
Right, but then how would you prove it's true if you're just simplifying it? I guess is the problem.
Yeah, because so this one is asking if it's equivalent, but this doesn't.
Right.
This one's like the proposition. So
That's
personally, I wouldn't say it's true, but as long as you show your work, I think he'll know what's up.
Go ahead and do your way. I'm just curious to see how it all pans out, because I could definitely be wrong.
Yeah.
Can't you use a truth table on these two?
Yeah, but it takes too much work.
No, I got you.
Personally. Okay, so we're gonna skip that one, but I guess just answer to your heart's content, because everybody has their own opinion. Alright, so number 4 is kind of quick, bro. So basically, it's gonna ask if this has the letter A and if this has the letter A as well. So does orange have the letter A?
Yes. This better be on the test. The one that if it's not on the test, I'm gonna be pissed.
It'd be really easy. Okay, so yeah, A is true and
I
B.
think this one was on last year's test, and it was like 12 points
Let's
on the
go.
old one, like that's one point in the Discord. So.
Let's go.
And also last time he didn't put a lot of things on the review, but they were in the last year's test, so you might want to look at that.
Whoa.
From the
There's a
notes?
last year's test. Where do I find it?
How do you?
It's in the exam help in this Discord at like the top.
Nice.
So do check that out, because like the graph problems were on there from last year's, but they weren't on our review, but they ended up being on our test. So yeah.
Wait, where is this thing?
Out there, the
He's just so lazy that he's gonna copy it and paste it. It's just gonna be the same thing.
And why aren't we going over the last year's test?
I did not know it existed.
Where is this exam review you said?
I'm looking in the.
It's in the
I can't find
the
it.
exam room. I just opened it.
This is 2013.
Exam review, yeah.
I mean, this is 2013 though.
Yeah.
It's not last year.
Yeah. Oh well, same thing.
It's
Sort of.
Okay, well,
Either way, it still
I
has the
don't
same
cheat,
question.
so-
So
I don't.
yeah. You want to finish this review first, and then we'll go look at the other reviews then.
Let's do
sorry, I
that.
just thought I'd mention that.
Yeah, because I want to
Thank
play.
you.
I want to play Minecraft with my girlfriend. Anyways,
For all
okay.
first.
Run this one. Okay, so what basically this is asking is to find like an equation for this whole thing. For this one and this one. We know that P of X I can just copy paste, is the Nutrix. And Q of X is predicate logic. R of X is old, and the domain is dogs. And domain is dogs. Okay, quick reminder. So there's two things that you're gonna have to remember. The backwards A. I don't know how to do that, but anyways, this is supposed to be
somewhere in this. It's on 6. You can copy paste it. Maybe on. Never mind.
Okay. All right. So backwards A. Jesus. Okay. Backwards A means universal, which means everything has to be true. Every domain has to be true. And
wait, I had a question about backwards A. Like, how are we supposed to write that in the exam?
I'm pretty sure he'll say something about it.
Okay.
But I would say just put.
Yeah.
I would say just put A, because that's what he did on the other one. So.
Okay. And then for E, just put E, where existential are.
He also told me that you can just write in plain words like for all instead of the upside down A. So I guess either works.
Okay. All right.
And E would be some.
Yeah. So some old dogs need tricks. So you'd really have to pay attention to the wording on this one, right? So some means not all. So that means it can't be universal because everything has to be true, right?
Right.
So it would be, the first thing you'd put is existential.
X.
For
Or is it X and D?
Yeah, so like that. And then it's old.
X. Oh.
It's old, and then Nutrix. And P of X has Nutrix, and R of X is old. And
RX and?
Yep. So it'd be P of X and R of X, because there's no OR here, right? It's not like some old dogs or Nutrix. It's like saying that they both have to be true. Does that make sense?
Yep.
So the equation here would be P of X times R of X. Does that make sense?
Yep.
And no dog knows predicate logic. So saying no dog knows predicate logic means it's saying that
negation.
Yeah, it's negating. Thank you for that. I was kind of stuttering. And it's universal because it's saying every dog doesn't know predicate logic. Does that make sense?
Right. So just like apostrophe, backwards A, ND, QX.
And predicate logic. Yep, it'd be QX. And all of this whole thing is going to be negated because of this no right here.
So the one thing that I did notice about this is it says that we can't put the negation symbol before the quantifier. So I don't know if that still counts as before because it comes at the end, but like
wait.
I remember we had to move the negation symbol from out front, like inside to where the Q is, but I don't know if that's the same thing or not.
It is the same thing. It is though. I think if you were to change it, it becomes some, not QX. Like, right?
It just
Yeah,
really weird questions. I don't.
Yeah, they're saying right. You can't apply the little not
negation
sign
on the
outside. Yeah, you have to put it on QX, so then the A would become some, not
E.
all.
Yeah. So that equals sum of X and D, not QX.
Yeah.
So.
Well, like I was looking at.
Doesn't mean the same thing.
Yeah, because I was looking at my professor's thing, and this is what he has, or like his little knot thing was over here, like on the side right here.
Yeah.
So I'm like, I guess whatever.
Yeah, but it says don't do that, and I'm like, well, what do you want us to do? You're not giving us the right stuff to work with.
And that's what he does. Like, what am I supposed to do? You know?
Oh yeah, no, it's not you. I'm mad at the professor.
Yeah. but we're in college. It's a scam. So, anyways,
It is.
Oh, facts.
And the only reason like the thing even comes up is because in the negation, like the all does become some. Like that's a thing that he taught us in the notes. So like that is kind of a weird thing. I think he messed up somewhere, or I'm not sure.
Okay, so this one's kind of easy as long as you remember the definitions from the notes. If you guys look at page 6, that says finite domain. But I'm gonna put it down just in case. If you guys don't want to.
PA, and PB, and PC.
Yeah, so this would become... So this is universal, right? And remember that we said that everything has to be true? True, right? So to make this into an AND, OR, and NOT operators, we know that to make a value true, for everything true, we can just AND everything. And these expressions are going to help us. So it would be PA and PB and PC. Does that make sense? But we're just going to do it we're just going to do it this way.
Yep. So what's weird for me is for all becomes and there exists becomes or. That's the weird part.
Yeah.
Hey, Jerome.
Yeah, what's up?
So just to make sure I'm following, like you have A where like everything is true in this domain. So you have to do like and for like each function.
Exactly.
Like, okay, got it. Cool.
So yeah, so for every domain, everything has to be true. So you just AND everything. Because if one of them's not true, then it's not going to be true. It's not going to be like 1.
Right. I gotcha.
In terms of binary.
Thank you.
Yeah, you're welcome. So existential is just like only one thing has to be true. Only one thing has to be true. And this would just become the same thing, but instead of and, it would be pluses. Seems simple enough?
Yeah, somebody's asking about the Discord. I'm gonna send them.
Yeah, go ahead. Okay.
You?
And for existential, it would just be equals this whole thing, but this quote-unquote whole thing is going to be knotted because of the negation sign on the side, right? And in this situation, we can just use the De Morgan's theorem, which is P of A times, times P of B naught times P of C naught. Does that make sense? Since it's the same thing, but the only problem is that we have a negation thing right here. So we negated this whole equation, and we had to use the De Morgan's theorem to get this answer. You guys good with that one?
Makes sense.
Yeah, this one's easy.
Yeah.
Yeah,
Did he work this?
Yeah, that's right.
What?
Did he work this one out in class?
I think so.
I think he did, but I never paid attention in this class.
Yeah, I didn't even go today, but I should have. What is or yesterday? I mean, what is quantified statements? Like, what is that thing?
Quantified statements? Okay, quantified statements is these things right here. And what he wanted us to do is kind of just convert it as logical expressions. And that's how we got these answers right here.
Okay, I gotcha. But like what I'm confused is like, how'd you know to use and on the first on A or on B and then not on C? Like, how'd you know that?
So A means universal, right? And what that means is that everything has to be true.
So I know that I'm saying like for like A, like the whole thing A, B, and C. You know how we have those? How'd you know to use and on the whole like universal P of X and then use or on the existential P of X and then not on existential? Like, how'd you know which one goes with what?
It's a formal definition. Can someone mute their mic, please? It's a formal definition. Sorry. It's not very good. It's on page 6. If you look at his notes. from today. And if you have any more questions towards that, you can ask me again. But it tells you on page 6 on the notes that he sent out today. That good? And trust me, it'll make sense because it literally looks the exact same as what I have here.
Okay, I got you.
Yeah, so just check up on that page. Any more questions? All right, now, okay. Okay, this one's another weird one. Okay, so this would become, let's do step A. So we're gonna do the left-hand side first. So this would become not.
Okay, I had one question about like this kind. How do you determine if something's true when there's no equal sign? Like what I really don't get.
Yeah, I know that's my problem.
I agree with that actually. I
think
I thought that implies you can just rewrite it as not the first thing plus the second thing.
Yeah.
You can, but sometimes implies does mean equals. I just don't know when.
So to try to find if it's equal, you take the left-hand side and the right-hand side. If they come out to the same exact thing, then they're equal.
Yeah, so like
I know, but why don't they use an equal sign?
No, if there's an implies, the left side has to be primed and the right side has to be normal. And if they're both equal after the piece primed, then that's when they're equal. Does that make sense?
Okay. Yeah, well, I guess that's how you do it.
Yeah. And in this one, I'm looking through his notes and it says it's only true in some situations where it's only true on some specific values where like A is 0, B is 0, yada yada yada.
Okay.
So like it's not true in all cases, but it is true in some cases, and you just gotta.
Okay, that makes more sense then. Okay, I get it.
Yeah. So we're gonna do this one first. It's gonna be the De Morgan's theorem again. Do I really want to do it? Just come out to the same thing. Oh, you know what? Fuck it. Okay. So it become A naught or C naught, and then that whole thing is gonna be knotted. No, what? Okay, yeah. So plus B and C. And then this whole thing right here. And we're just gonna simplify this to
Why is it B times C? It's supposed to be B plus C. The De Morgan's thing doesn't apply there. Why does negation apply there? That should be normal.
Okay, so we're doing this one first, right? And remember that our property is P
not plus Q.
Yeah.
Yes. So that's what I'm saying. The P not applies to A plus C. The whole thing gets a not applied to it, not the B plus C. Why'd you make B plus C into B times C?
Because this is end, right? So it's just B C. It's just B and C. Nothing changed. That's what you're asking for.
B caret C is the same thing.
Yeah. So this is the same thing as this. If that's where you're confused at, bro.
Oh, okay.
Let me just put that on there. Sorry. All right. So we got this whole thing here, and now we can simplify this one right here. So it become this whole thing. Jesus Christ, it's Jason. Knotted, then plus this thing, right? Then we're gonna, yeah, we can simplify this one first to make life easier for both of us. So this prime, it's gonna actually just get sent out to the whole thing. If that makes any sense. Because this prime right here is gonna be sent to all of these variables, even the operator. De Morgan's theorem. So this one would go back to AC. Just AC. And B naught or C naught plus this. And the next thing we're going to do is simplify this. then yeah, I think we can solve from there. Any questions before I continue on to solving? Can you guys hear me? Or not?
Yeah, so you
Yeah.
basically just removed all the implies.
What?
You basically removed all the implies.
Yeah, so you want it to
And
where it's like as simplified as possible, just so you can solve it from there, make things look easier. You know what I mean? Okay. So what I'm gonna do is I'm gonna take the parentheses out so it doesn't look weird. So in this situation, I'm gonna distribute this to all of here, right? So this will become A naught plus A on C. Does that look right? Yeah, it does. Just looks weird.
So far.
Just looks weird. Times A naught plus B naught plus C naught. Right? And then plus A naught plus B. So what I did is just basically kind of expand this. So I multiplied, I distributed this to this, and this to this. Do you guys see that?
Yes.
Okay.
You distribute A to the whole thing.
Mm-hmm. To X and Y, yeah. And in this situation, you can distribute this thing right here. So it would be A naught plus A times A naught plus C, right? And then this whole thing. And do you guys see
So
anything?
that A naught and A is 1.
Mm-hmm.
I think.
So yeah, so that would be 1 A naught or C. And this whole thing. And you can just delete that thing. So it would be A naught or C. A naught plus B naught plus C naught. Did I do something wrong? Just tell me if I did something wrong so we can fix it.
Well, you messed up that G.
Yeah.
The A naught, you distributed it, but you still kept it in the next step.
Which one?
At G and H. G and H, I feel like.
Okay, so I distributed it like this, so it's gonna be A naught plus A times C, and then I multiplied it by A naught plus B plus C. Alright.
Yeah, but the A naught is still outside, like after.
Yeah, the A naught's still at the end.
Oh, okay. That's why there was an extra one. Gotcha.
Yo, I did truth tables for this one after not getting the answer for forever, but wouldn't.
Alright. And for this one, it's because I usually do it differently. That's why I'm just like, what do I do next? We can take out A naught. We can take out A naught, and
it would be plus though.
B plus C naught, B naught plus C naught.
Like that.
Yeah.
And then is it gonna be plus C as well?
Yeah, and then plus C.
No, it's gonna be times C, right?
Really?
C times B naught plus C naught.
Okay.
Unless I'm doing it wrong, that's just what I would assume. Because the C is being multiplied to the first term's being multiplied to the second term there.
So it'd be B naught C.
I think it would be like this.
Yeah, that's what I was saying. At least that's what I think.
Yeah, just correct me if I'm wrong.
That's right.
And you can distribute this, I believe. So it'd be A naught plus B naught C plus C naught plus B. And this one turns to 0 because they're inverses of each other.
Yeah. And then you should be able to eliminate one of those terms there too. I think it turns into either C plus B or C plus B naught there at the end. I can't remember the law.
Let me just do the long. Let me just do the long version, if that's okay. And then this would just become A naught plus C plus B. Same thing he got. Awesome. Yep. That's it. Ooh, Jesus, that's like what, 20 steps? Holy crap.
Holy crap. And that's supposed to imply A implies B, right? Or that's the simplification.
That's the final one. I'm looking at the professor's and it looks the same as his. So
what are we supposed to do for the text box on the test?
Pardon?
Say that again?
Like the text box on the test, do we have to put all of that in there?
If you want credit. If you want
really?
A lot of these steps.
That's what's dumb is that we have the text box and we have to write all that shit in.
Yeah, they make showing work really hard, but I don't know if they get partial like credit for showing.
We do.
Yeah, we do.
I was talking about,
Yeah, we get partial credit.
Then, yeah,
but we should just be able to submit a PDF. Like that's what we should be able to do.
It would be nice, but
Like just of our work at least.
So
He legit doesn't care enough.
I had a question.
What?
There's a question really soft.
Okay.
Oh, I'm sorry.
Go ahead.
So in the 7th one, they're telling us to determine if this proposition is true. So we got the answer, but how do we know whether it's true or not? Shouldn't we get like answer is 1 to show that it is true?
It's only so what someone said. Checking the truth table to see if it's right is a good answer, but
I made a truth table. It took a really long time, and then finally the answer was true, false, true, true.
Yeah,
so that means it's only true in some cases. That means
only
like
one
it's not
case
true
where
or
it's
false.
Yeah,
so
There's only one case where it's false. It's if A is 1 and C and B are 0. That's the only case where it could be false.
Yeah, so what he was showing in his notes, that it's only true for some values. So as long as you find one true case for any of the values, then you're good. Just say it's true when A is 0 or B is 1 or C is 0.
So in my truth table, A, B, C being true is good. The only time it's false is when A is true and B and C are both false. It's a truth table. I don't know you guys.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8 columns. You have A, B, C, C naught, B or C naught. A implies B or C naught. And then
I mean, there's like 20 of us watching. I think if he made a mistake in his work, we would have caught it. So I assume that's right. A naught plus C plus B at the end.
Yeah,
that
we're
actually looks like
supposed to
what I
write.
got.
From his lectures, all he said was like, if you get this, that means like you just write. It's only right in some cases. You're not supposed to bring out like when it's right. You're only telling them it's just right in some cases. You don't have to write a truth table.
Thank God, because I wrote a big ass truth table just making sure, and it was
No, we
only
don't have to
true,
do that.
True, false, true. So annoying. I wish it was always true, but it's not.
Yeah, but if you get 1, then it's just true. If you get 0 in the end, then it's false. But if you get like letters or whatever, that means it's true in some cases, false in some cases. It's just we don't know, so you just leave it at that.
All right.
In the answers he uploaded today, he says, and the values for A, B, and C such that the original equation is true, and so A equals 0, B equals 0, C equals 0. Make that statement true.
Interesting. Well,
that statement
that's
true.
not the only example.
Yeah, so just say it's true in some cases, but not all, and you guys should.
That sounds like a plan.
Okay.
All right. I'm kind of
I
confused.
want to look at his notes, because I mean his notes make no sense to me. But like it's like EXD is equal to 1 or 2, P1 is 0, P2 is 1, Q1 is 1,
Okay.
Q2 is
Okay.
0.
So that's just him putting some values. to prove if it's true or false, right?
But we have to do the same thing here. So that's the thing. Like we're supposed to make a domain, and for the domain, we're supposed to assign if P of 0 is 1 and P of 1 is 0 or whatever, like that. How he was doing in his notes.
Yeah.
And we're supposed to prove how this is true from all the stuff he showed in like October. I don't know what date exactly,
So-
but we're supposed to come up with that.
So this one, I'm gonna skip with this one. So because this is kind of like the question I'm iffy on, but for number 9, it's pretty easy. So if you guys are fine with me skipping to number 9, that'd be awesome.
Okay.
All right. So we know.
If someone else wants to tell us how to do it afterwards, that'd be nice.
Yeah, for sure. So proposition 1 is saying that this P2 is this and Q is this. What he's saying is just basically find if like it's true. That's all I can say. So the first thing we're gonna do is we're gonna find values for A, B, and C, because this is propositional logic, right?
Right.
Yeah. So what it's asking for if P1 and P2 are true, so we're gonna do P1 and P2. Determine if the following proposition, if you see that proposition, that means you put the little arrow sign right there, is always true, and prove your answer. And this is the thing he gave us, right? So it would be Q. So if it's always true, then it's going to be Q. Does that make sense?
Yes.
Okay. So
You have to and them basically.
Because both have to be true. So P1 and P2 are true. Then you can switch to Q, or you can go to Q. All right. So what he did in the notes is just what I'm gonna do. We're gonna have 3 different statements. The first one being CS is difficult. The second one being many students like CS. So for now, just ignore the not parts, because you can just not it in the equation. Does that make sense?
Yes.
Yeah, so it would be A equals CS is difficult, B equals students like CS, and C is equal to math isn't easy, or math is easy. Okay, so if you look at P1, it's saying that CS is difficult, so that's A, right? And
Or.
Yeah, so it'd be or, which is the plus, and not is a negation, and then students like CS, so it'd be B not. Does that make sense?
Yeah.
And
Do we just ignore the many then?
where?
Because it's many students, do we just ignore that?
Oh, it doesn't matter, but I'll put it down. So for P2, okay, this is really important. So if you guys see an if, that means it's propositional logic, and that's the thing that goes on the left hand side, right? So it would become.
Oh, it goes on the left.
Yeah, if it's if, that's the thing you put on the left. So it becomes C, and then the proposition of A naught, and it's not because of the difficulty of the not right here. Does that make sense? And this is where it gets tricky. So Q is math is not easy if many students like CS. If you guys see if, the one that goes after the statement that goes after the if, that's the thing that you put on the left hand side. So many students like CS, that's B. And then since we saw the if, it's a propositional logic, so it's B. Math is not easy, that's C. Does that make sense?
Mm-hmm.
So all we have to do now is substitute. All we have to do now is substitute these values and solve. So P1 is A or B naught multiplied by this and proposition of Q, which is this. and these are knotted. So that's the first step. So personally, what I like to do is I like to take these out of the way. So I'm gonna do the inside function first. So this becomes C naught or A naught. Yeah, whoever said that. Or A naught. And then just this whole thing. And then we're gonna do this one, just because it's an inside function.
Not all of that. Plus B.
And then this is the last one, so we're gonna do this one. So what do you guys think is gonna happen to this one right here? Like, which one are we gonna knot?
The right hand.
The left.
The
You're gonna
left.
knot the left side.
First part.
Which one on the left?
The
all
whole
of it.
thing.
The entire thing?
Yep.
Yeah, the entire thing.
thing.
Oh yay.
Yeah, and then or this
When
whole
we
thing.
when we negate that, do we only switch them to A B not plus C not plus A? Do we have to do the inside switched as well or no?
What does that mean?
I think
When you
negate, when you have like the A plus B prime, whenever you like dish out the prime there at the end, you don't change the insides. I don't think it's just you add that prime to those two parentheses in between. You add the plus sign.
Yeah, so it would change either way. So you'll see what I mean. You'll see what I mean.
Yeah.
So like
it changes every value inside everything, the signs and the like ABCs, all of it.
Do you flip those two? Oh.
Yeah, look, I'll do it step by step so people don't get confused. So it would be not right here, and then plus, because of De Morgan's theorem, remember. De Morgan's theorem is really important. Right? And then we do the inside values. So it would just become...
A and B, or not A and B.
Did I skip a step?
No, I think you're good, honestly. That's what I have from these notes. I think you're doing fine.
Okay, thank you.
Not A and B.
A not B plus C A. Am I sure I didn't skip a step?
Yeah, that's correct. That's correct. C, A, or B, or C.
Okay.
Or B.
Or B not or C. Does that make sense to you guys?
That does make sense.
De Morgan's, yada yada, all that skippy stuff.
But okay.
And after that, let me see. What did I do? Oh, okay.
I'm gonna group the B's together or something after that.
Yeah. So you can group this and this. Like there's a formula for that, or there's a theorem for that. But I'm just gonna show you guys what it looks like, just so you guys don't get confused. So it would be B naught or A times B naught or B, and then this whole thing right here. Does that make sense?
Okay, you distributed the B to A naught and B. Okay. Did the B to A naught and B, right?
Yeah. So let me rearrange it for you guys so you guys see what's happening.
And change the A to an A naught, I think.
Which one?
On number 7.
In the first parentheses, yeah?
Yes, in the first parentheses.
Gotcha.
Okay, that makes sense, yeah.
Yeah. So in this part, I just rearranged it so you can distribute the B to this and this, right? Pretty simple. Okay. And we can simplify these now. So this becomes 1, so this is gonna be gone because it's 1. So it's just gonna be B naught or A naught or CA or C naught. And then you can there's two choices you can do here. You can distribute A naught or C naught.
Let's do A
Yeah.
first.
Which one?
So it becomes A I guess.
Yeah, so we can do that. So it's B naught or A naught or C multiplied by A naught or A. Or C naught.
Yeah.
And this just becomes 1. This just becomes 1, and then now you can just do B naught or A naught or C naught. And this becomes 1.
And the whole thing be true then. And it'd be B or A or 1 be equal to 1.
Yeah. Oh wait, it's what? Wait.
I think I saw somewhere on one of the
I missed something. I just don't know which I missed.
because I think on his call that his notes he has where he has A or B naught or 1 is equal to 1. So,
Yeah. So it's supposed to be B naught, C naught. Oh, B naught or C naught, but I don't know what I did in this one. B naught or C?
I mean, B. You're trying to do B naught or C, so you can do the implies, and it'll become B implies C. But
Yeah.
What she said also is true, because if you have +1, then the whole thing is 1, which is true.
Yeah. No, it's because my problem is this one.
If instead of taking that A, do it with the C. So like make it C naught plus
that's what I
A
was
plus
thinking.
A naught.
So we should just do
Yeah,
it with
sorry
C.
about
No, you're good, bro. You're awesome for speaking out. Okay, so like that, right?
let's see. I'm excited to see the final exam, like how it would be. Not gonna lie.
So it would be B plus.
I don't know if that part's right.
Yeah.
Because you still have that A naught left.
Yeah, you forgot that A prime.
You can make it C naught instead. With the last one, you can make it B naught plus C naught, and then change it to B implies C naught.
I think it's just because I skipped a step here. So give me a second to focus. A naught or B plus CA plus B naught plus C naught. I'm sorry.
You also made a mistake at line 9 and 10.
Yeah, I know. Just give me a second. Plus C or C. This becomes 1, so it's B. A naught C or C. This one. A or C. Okay. I think I'm just gonna start over from here.
Start over.
Not start over. Start over. Okay. All right. So this one, I would distribute B naught. B naught. Trust me, I promise I got this one right. Watch. B naught or A.
Okay.
CA plus C. Right. So this would become 1. So that would cancel out, and then this whole thing would just become this regular thing right here. B naught or A. CA or C naught.
Looks good so far.
Yeah, and then I'm gonna try to distribute this to get the whole thing. Or I can take
C plus C.
You're on the right track, I think.
I hope so. I'm gonna be upset.
If you distribute the C naught, you won't end up at the same spot you were last time.
Yeah. What's the move here?
You're already in a better spot.
C plus C naught times A naught times C naught, something like that.
Yes, C into C and A.
Yeah. So
Because that would get rid of the C and C naught, which is the one less term we have to worry about.
Just become C naught plus A.
then since A is there, we can. Is this supposed to be a naught?
Take
Right?
the A out.
I mean, we can just group the A or A is gonna be A anyway.
A plus
So that's how C naught or C naught or A.
It's supposed to be. Oh no, it is supposed to be not. Okay. Oh yeah, you got it.
Yeah. I kind of went stupid, go crazy. There. All right, I think. Yep, this looks right. Awesome. Baka. Watch anime too much. Okay, so this and this would become 1. Oh, thank God. So this is B naught or C naught, which is equivalent to Q. So thank God. Does that
I
make
think
sense?
B naught plus C naught plus 1. Isn't that just like 1 in the end, or am I
What do you mean?
crazy?
It's also
Isn't
1.
that one of the things where you can just group B naught plus C naught and then have plus 1 in the end?
Okay, so in this
some term
in this situation, I
some
think
term plus 1 is 1.
That's also true.
yeah, that's also true. So you can do that as well. But what
The
I was
answer
trying
is
to
just 1.
what I was trying to do is make Q equals to this. So it was right.
Okay.
Does that look right?
Yes.
So we did the little like implication form right here. So B naught turns to B, and then plus turns to the arrow, and then C naught is just the regular thing. Does that look good?
Yeah.
Yeah, sorry it took a while. Okay.
You got it.
Right. So number 8 is where I'm confused at. So if anybody else can take over, I'll send you my notes.
Can I ask one quick question real quick on number 9?
Yeah, for sure.
In the beginning, why do we and all of them together for the most part? Like we have, like I get how we get P1, P2, and Q, but I don't get why we set it up like that.
Why would end right here?
Like in line 1, like I get where we get the expression from, but not the whole expression. Like why we and like 2 terms and we imply another.
Okay, so if you read the problem, it's asking if suppose that both P1 and P2 are true, so they both have to be true. That's why I did P1 and P2.
Gotcha.
And then determine if the following proposition, that's what the arrow means, is always true. And
Gotcha.
yeah, does that make
Okay,
sense?
thank you. Yeah.
Okay. Anybody else know how to do number 8? I'm kind of confused on that part.
Here, wait, let me see it. It doesn't look. Oh, fuck. The upside down A's are in there.
Yeah. Like
I don't even know what happens. Like, so you put in 1 and 0 and 1. What does that mean? Like,
See, I think I know what it
Oh,
wants.
Yeah, it's just saying is all of P or all of Q the same thing as all of P or Q.
So reading his thing, it's asking if it's always true.
This is kind of weird because from his notes, if it's a question like this, then the left side is implying right side, not equal. So I don't know why they're asking to prove if it's equal because he's saying it's not in his notes. I don't know. I mean, there are some cases where they would be equal. So does he want us to find like an exact case where that would be equal?
The question's like really about the notation there with the A. It's basically it's just like all of P or all of Q, is that the same as all of P or Q?
Yeah. So right here, look, it's saying so A 0 and B is 1. So that means this isn't true, right? And this is or, and this isn't true as well because it's universal. So 0 or 0.
Wait, I have a question. Is it supposed to be implied instead of equals to? That's what the question says, implied.
Oh, on number 9?
Number 8.
Number 8.
Yeah.
I don't think it says implied
Well, I
anywhere.
think it just implied.
The implies is what it's supposed to be, but this says equals, which is why it's wrong. If it was implied, then it would be right. The for all implies for all P and
Yeah. So if
P or
if it's implied, everything of this would be flipped and this would be true, but it's not. So I think what he's asking is that I already know there's cases here where everything is true because if all of this is 1. Like if PA is 1 and QB is 1, then this would be right, then this would be right, then this whole thing would be right. So
that's what he wants us to do. I think that's what he wants us to show a case where they're equal. Implies is what the formula has given us already from his notes, but we're supposed to find a case where they're equal, both sides, and it's not implying.
Yeah. So
yeah, that's true because he just says determine if it's equal, but like he didn't say for all of them or anything, and it's not really implying anything. So the question's kind of worded badly.
Yeah.
So you don't know if it just means do it for like
Wait,
one,
so
so give it one specific example.
Wait. So for 8, I think so for 8, all of P has to be true on the first part. All of Q has to be true on the second part. On the third part, the equal sign, all of P and all of Q has to be true for that to be true. So the false case is when you have one side being true, the other side being false, meaning all of P is true and some of Q is false. So when you OR that, that whole thing becomes true.
Exactly,
But
because
if on the other side you have two things that are true, but two things that are the third and fourth thing are false, that is false. So that's why they're not equal.
yeah. So if they were given by this equation, like if you're looking right here, he says that if this is like the domain, then the left hand side would be 0. However, if that's the domain, the right hand side would be 1. So this was 0 and this is 1. That's why it's not true, or that's why it's not equal, because they don't have the same value.
Wait, I kind of have like I'm kind of confused right now because, okay, so P of A is 0, which is the first one, and we know Q of A is 1. So when we say like 0 or 1, right, which would be still 1.
Okay, so you'd have to do the inside function first. So this is asking for if P of X is universally true, right? But the problem is it's not, because A is 0 and B is 1. So that means this is not true. So this would be 0, and this would be 0 as well, because A is 1 on Q and B is 0 on Q as well. So this is 0 and 0, or 0 or 0. So it's going to be 0. Does that make sense?
Okay. Makes sense.
Joe, could you go over this one thing in the notes? Okay, if you can.
Yeah, I just had to look through the notes. I had to find my notes real quick. Give me a second.
So what I'm asking for is this really, really long one, and maybe you can just like look through it and explain it. The really, really long one in the notes that he didn't finish. Like, what was he doing?
Which one?
I forgot where it is. Let me
But yeah.
It was like P not Q, R not implies S, S not implies T, T not implies U.
Oh, that one. I don't think he's gonna give you that long of an equation.
Okay.
Don't worry about it. So this is basically the same thing as number 9, but number 9 is shorter.
Yeah.
So don't worry about it, man.
Yeah, he didn't even finish it. Basically, his final answer was ugly.
Yeah. Yeah, don't worry about it, man. I don't think he's that fucking fucked up. All right. Well, that's it for the notes. I'm gonna try to tidy it up a little bit, but yeah, I'll send the review at the exam review chat, and if you guys have any questions, you can just stay here.
Extremely helpful.
Oh yeah, for sure.
I have a question.
Yeah. What's up?
Can you please go over? Hold on, let me tell you. Can you please go over page number 4 of his notes, like where he did this exercise that it is not sunny and cold and sort of, and the problem was huge.
Oh yeah, that's what he was talking about. Like this whole thing right here that I was showing you guys. So you don't have to worry about that one, I don't think, because it's just basically the same thing as number 9 in the notes, right? If you look at it closely.
Yeah, I didn't understand how he solved that. I was just wondering what logic went behind solving part, because I looked at his video and I didn't understand anything.
Yeah, so he actually didn't finish it because there were so many variables, and like it would take him forever just to like try to finish it. Because it takes me a while to even do just 2 variables.
He was trying to get people to use simplification, not basically.
Yeah, he was trying
to simplify it.
He was trying to simplify it, but he was like, "Nah, fuck it."
His final answer is really long.
Because he knew he messed up somewhere, but he doesn't want to look through like 30 lines of just simplifying everything.
I see. Could you actually go up those notes?
Yeah. Where is it? Okay. Up?
Yeah, if you just go a little up, and the C one. I didn't understand statement number 4.
Number
That's
4?
Yeah.
Okay. We can work this out real quick. If you guys are just here for the review, you guys can go, but anyone else that wants to learn more, you guys can stay. Okay.
These are nice.
All right, let's put this where.
This is just like a question in the review. Right?
Yeah, it's the exact same thing right here.
Yeah, it was like.
Yeah, it's exactly the same thing.
Also, this is the solution. Literally everything in the review.
Yeah, no, if you notice on the
That's
last
impossible.
test, all of his notes, he basically copies the questions and then changes a single number. And so on the last test, I had all the notes printed out and straight up, like half the questions were the same thing, and I just took his answer and then did some like weird moving around of my number in there and figure out how that translated, and it worked out. So more likely than not, if you have the notes, which I recommend you have on you when you like have it or whatever, because you can have the physical notes, have those on hand and like study those, and then study the review. And while you don't have to know all of it, just make sure you know like some of the questions he had on there and how we worked them out. Just so if you like get that on the exam tomorrow, you can look at the notes and be like, oh shit, that's what this is, and then like figure that out if you don't know what it is.
How ready do you guys feel for this exam tomorrow?
I'm nervous as fuck, but I think I'll be
I am
fine.
too.
I just need to get an 85.
Yeah, I fail out if I fail this test, so.
Yeah, you do.
Brain.
You as well? Sick.
I think they can get a 70,
I mean-
so I'm okay.
I got a 66 on the first one, so.
Yeah, I got a
Yeah.
68, I think.
I
Hey,
actually
if I get a 66 on this one and I got 100s on the last two, I can still pass.
Wait, really? Oh fuck.
That's motivating.
Yeah, I'm not putting my money on that.
yeah, no, the only that like when I mentioned the whole trickery basically has is like the notes are the same thing on the exam. That is the only reason I did like passably good at that exam.
That's the only reason I
Fucking
didn't.
saved me.
Like this time, the reviews exactly like the notes he made. They weren't even changed.
Sweet.
Now that
So
you know
on the
the
test, it
format,
should just be like
be
that
better.
same thing, hopefully.
Can
Exactly.
you please go over that one, like the fourth step?
Yeah.
I was having a confusion.
Yeah. So I'm gonna try to fix it as we speak.
A plus
I don't
B.
think we finished this. Now that I'm looking at it.
Yeah, we just kind of skipped it, so it's a good time to.
Yeah.
So he negated the left side, and no, he did the implies rule, and
Yeah, I did the implies rule on this one. So for the inside function, I distributed this, and I still need the not right here. Right.
Mm-hmm.
So I'm gonna knot everything in there. So it's gonna be AB plus AC and not. Sorry, forgot about this part. But
Wait,
that was good.
yeah?
what's up?
I don't think I understood what you did.
Oh, okay. The De Morgan's theorem.
You distributed the A.
Yeah, so let's take this a step slower. Okay, so it would become this A plus B, and you distribute this whole knot thing, right? And it's plus A plus C,
Oh, gotcha. And
and
then
not.
not.
And just this whole thing.
Yeah.
And so like right here, I just do the De Morgan's theorem. So it'd be A naught B, A naught B, plus A naught C naught. Does that make sense?
Yeah.
Okay. For how we solved it, I'm not really sure, but we'll go through it. We can take out the A naught.
That A plus C. Yeah, that A plus C can become A naught plus C naught, right?
Yeah. Okay, let me see.
You take out the A naught. And then
So it'd be, I think this would become A naught, then B naught plus C naught.
That looks right.
Hopefully. Okay, stop.
even if it's different from his
And
note,
then-
this is correct.
Oh, and then I can
Yeah.
I can distribute.
You do the same with that side.
Yeah, I can
I think.
can distribute this one too.
Or I would say distribute the A like you did on the left side, yeah.
So yeah, so it'd be A, B, or
Equals C.
C.
Did you mean to get rid of that last or?
Yeah, B or.
The one there, and then you can do the whole X prime Y, and then X Y thing. Okay.
Okay, this one, I'm kind of lost. Wow.
I think it's A prime plus BC, and then that and A. No, fuck. What is that? Hold on, let me find it. It's one of the.
If I look at the notes, it says A plus B prime plus C prime plus BC.
Okay, let's see what he does. A plus B plus A plus C. Oh, so what he did is he distributed it. Okay, let's just do it like that.
Yeah.
I was doing it to simplify it, but I think
which one
I
is that?
guess this is easier. I don't know. AB plus AC plus BC. Are you guys good with that?
Yeah.
Why does he have an extra A? That's what
Just my brain is like there should be 4 terms because algebra, but it's not. It's not algebra.
Yeah, it's really weird, man.
Right.
Okay,
So
so this is where you got confused. This whole thing right here, right?
no. The next step.
The next step.
But
Yeah,
he
so
just
how do
he
you
did it
solve
different.
A prime bracket B prime plus C prime.
It's still here. Oh, how did I get this one?
No. How?
Basically,
so the
everything with
next
A's
step-
disappeared.
Because
Oh yeah, the next step.
Yeah, I think all with a lot of things with the A disappear because of the absorption theorem. If you guys don't know what the absorption theorem is.
What's that? Well, I know it. So on this review it says A, C, and AB disappeared, but like ISD.
Here's these rules.
Yeah, so you can show the rules. So okay, so everything that's ORed right here, if there's only one value and all of those values are kind of connected right here, you can just remove these because everything just turns to A. I don't know. It's hard to explain.
So if you don't know the absorption theorem, logical equivalence, 11th one, 11th law applies
Oh, I
there.
have to look at the rules.
Yeah,
P
exactly.
plus P and Q
So
is equal to P.
that's the absorption theorem right there. So all of these are going to be gone because of the absorption theorem. So this would just become A plus BC. Gone because of rule 11, absorption.
Which is P plus P and Q is equal to P. Yeah, if you don't have them.
Does that make sense?
Yeah, it does.
Okay. And that's what you were confused on?
No. Then do the next step. I'm confused on the next step. How do you solve A dash bracket B dash plus C dash? How do you solve that?
A dash bracket C dash. So the 5th step is where you're confused at. It looks like he knotted everything in there. Oh wait, no he didn't. What? He might have done it wrong.
He did it extra, honestly.
Yeah, I think he did extra stuff on there. Oh,
yeah, this step looks like there's a lot of extra stuff that should.
Personally, I would do it like this. So it'd be A naught or A, and then it would become A naught or B naught or C naught plus BC. Because there's more than one way to do it. Whoever's asking for that, right?
Yeah.
So I didn't understand this.
Yeah. How do you do the A plus A naught and then make it A naught plus B naught plus C naught? I mean, I see you do it a lot, but I don't know what that.
Okay, so this is distributive law. Like I know this is a plus, but you can distribute A plus to X and Y. It's one of the rules, but I have to look it up. Number 7. Check number 7.
So you have P plus bracket Q into R. So you distribute that P to Q, and then you also distribute that P to R.
Yeah, so that's why I got these.
So here you distributed the A to that whole thing.
Okay, yeah, look. So this is P, right? And I made this into Q. And this one R. This parentheses R. Does that make sense?
That makes sense.
Okay.
P plus Q times P plus
then you did P plus Q. You did A plus A naught. And then you did P multiplied by P plus R. So you did
Yeah,
multiplied by
so
A. Oh, now I see.
yeah, so this is Q.
Mm-hmm.
This is yeah. So yeah, that's it.
Okay, let me actually and then how do you do it?
Okay, so since we know that this is A naught or A is equal to 1, you can just take that out. So it would be A naught or B or C naught. And then just what?
So that is 1. And then why did you not write 1 there?
Oh, I wrote 1 because it's not really important, but you can write it if you get confused.
I see. Okay, and so A naught plus B naught plus C naught you kept as it is. Wait,
Yeah.
where did you get A naught from? Was it
Oh,
like
I had
A
it backwards. Sorry, it's A. So I distributed this, so that's why I got this.
Okay, so now this is like the final answer?
No, not yet, because if you're looking, there, you can still distribute this, right? Because it's BC and this is B naught or C naught.
Mm-hmm.
So you can just distribute BC to each one of these.
I see. Can you actually explain me what the professor did, like the professor's technique? Like this, I understood. But like the professor's technique.
See, that's what I get confused about. So the fourth step, he did it through absorption, right? And I don't know why he did I don't know why he made everything to like A or B naught or C naught, because that's what confused me. If that makes any sense.
I think I know why he did that. So on the fourth step, he just distributed A plus to the thing on the left. So A naught multiplied by B naught plus C naught plus A. So
I mean, that's what I did, but it looks different than his. That's why I'm like, what the heck?
Yeah, that's exactly what you did. Why does it look different?
See, like if you look at the fourth and fifth one, I don't know why it got wrong. Like, look at it. So like
Yeah.
at the first
A naught,
expressions.
A naught and B, B or C became A or B naught or C naught.
So
but the B and the C, yeah.
Yeah, I think he just fucked. I think he just messed up, bro. Whoever was asking the question.
I see. So his is wrong?
I think so.
Oh.
Because the final answer is 1, so it shouldn't be this
Yeah.
one.
So can you actually proceed with this and get the final answer as 1 so we understand this?
Okay, so we can try to distribute this. So we can distribute this to this, and we'll have a good answer. So
And we can just remove the brackets like that, like without.
yeah, as long as you don't need the brackets. Like if it's just pluses, then you know, associative law, right?
Mm-hmm.
So you can just take it off. If it's confusing for you, you can take it off. I take it off because I get confused.
Okay.
So what we can do here, it'd be C naught or B and C naught and C. And then these two values. Are you with me so far?
Wait, what did you do?
I distributed C naught to these two values.
Gotcha.
Number 7. And this would become 1, then this would become...
Wait, I'm confused. Like, why did the AB go on the back? This question.
What do you mean? Oh, like right here?
Yeah.
You can move stuff around if it confuses you. So look, so right here, he got 1 because he did B or B naught or C naught or A, right? So like this thing right here becomes 1. So this whole thing becomes 1.
Gotcha. Okay, let me take a picture of it.
Yeah, for sure. I mean, I'm gonna put it in the Discord. So I guess just download it from there. Alright, so yeah. That's it. Oh, thank God. I haven't eaten all day, so I can't wait to just eat some food, bro.
Well, you gotta eat something.
I just have one more question.
I'm eating right now just because I'm just gonna look at this again later.
Okay. Hi, Pedro. All right, what's your question?
Hi, Jerome.
I was just wondering. Oh, where did your screw? Oh, hold on. Where
Where-
did my screen go?
Where did he screw up?
Oh no. Where did my screen go? Okay, never mind. So I was just wondering that in the exam he won't have such difficult ones, right? The ones that have like 6 to 7 variables that he couldn't do.
Yeah, I don't think so. I think it would like last like last review looks almost exactly alike than ours. His was just a lot of like trick questions. So as long as you kind of read the problem carefully and you do all of these problems here in the review, you'll be totally fine.
Okay, so all I have to do is just the problems in the review.
Yeah. And remember all your theorems because it really helps out a lot.
Gotcha. Well, thank you so much for your time.
Yeah, for sure. I like to help, you know.
Oh, thank you.
You're good at it too.
Thanks, bro. All right.
Yeah, thank you so much.
Smarter than all of us.
No, I'm not. All right. Well, thanks for stopping by, and I'm just gonna stop the call right here.
This was one.